Imagine a team of cosmic detectives. They stand on the shores of a planet teeming with life. That planet is Earth. Their case is an old one, nearly 4 billion years old. The mystery? How did it all begin? This isn't just any whodunit. It's the ultimate origin story. Scientists sift through clues buried in ancient rocks. They analyze the chemical whispers of bygone eras. They gaze into the cosmos, searching for answers. The goal is to piece together the sequence of events that transformed a sterile, rocky world into the vibrant, living biosphere we call home. It's a quest that takes us from the deepest ocean vents. For decades, the prevailing story of life's origin has been one of spontaneous generation. We call it abiogenesis. On a young, chaotic Earth, a primordial soup of simple chemicals was zapped by energy. Maybe it was lightning. Maybe it was the sun's harsh ultraviolet rays. Energy-fueled chemistry slowly built ever more complex molecules. Eventually, by sheer chance, some stumbled into the right combination. They formed a self-replicating structure, the first glimmer of life. It's a compelling narrative of cosmic luck. But what if it's too good to be true? What if the odds are astronomically against it? Physicist Robert Endres raises a cosmic eyebrow. He studies the building blocks, proteins, RNA, DNA. He sees staggering complexity. It's not just ingredients. It's precise, functional arrangement. Imagine a pile of all the letters of the alphabet. So, if life didn't start by accident here, how did it get here? This brings us to a fascinating and speculative idea called panspermia. The word itself means seeds everywhere. The basic concept is that life, or its essential building blocks, is not unique to Earth. It drifts through the cosmos, hitching rides on comets or asteroids. When one of these celestial travelers crashes into a hospitable planet, the seeds can take root and flourish. It's an elegant way to bypass the problem of life's initial creation on Earth. It simply outsources the problem to somewhere else, at some other time. But there's a more radical version of this theory. Enter directed panspermia. This is the sci-fi sounding version of the idea. It was famously proposed by Nobel laureate Francis Crick and chemist Leslie Orgel. To understand when this cosmic seeding might have happened, we have to travel back in time, way back. Let's set our time machine for the Hadean Eon. This was Earth's infancy, began around 4.5 billion years ago. The name Hadean comes from Hades, the underworld. Early Earth was a hellscape. It was a molten ball of rock, constantly bombarded by asteroids and by comets left over from the solar system's formation. An enormous collision with a Mars-sized object, Theia, blasted material into orbit, which eventually formed our moon. The surface was a sea of magma. The atmosphere was a toxic brew of gases. This was no place for life. But our planet is resilient. Over hundreds of millions of years it began to cool. Bombardment from space slowed. As temperatures dropped below water's boiling point, something changed. Okay, so let's dive deeper into the core of Robert Endres's argument. It's not just, a gut feeling that life is too complex. He actually uses the tools of his trade, mathematics and physics, to try and quantify it. Endres and his colleagues have tried to calculate the informational content needed for life to emerge. They focus on the process of polymerization, linking small molecules, monomers, into long chains called polymers. This is the fundamental step in creating proteins from amino acids RNA from nucleotides. In the primordial soup model, this is supposed to happen randomly. But Endres's models suggest that getting a functional polymer this way is honestly like winning the lottery 1,000,000 times in a row. He uses computer simulations to model the chemical environment of early Earth. In these models, virtual monomers float and connect according to the laws of physics and chemistry. Before we get carried away with alien gardeners, we have to give the mainstream theories their due. These are the usual suspects in our cosmic detective story. For a long time, the leading idea was the warm little pond hypothesis, famously imagined by Charles Darwin. The idea was fleshed out in the 1950s with the Miller-Urey experiment. Scientists Stanley Miller and Harold Urey simulated the conditions of early Earth in a flask. They mixed water with gases thought to be in the early atmosphere, like methane and ammonia, and zapped the mixture with electric sparks to simulate lightning. The result was amazing. They created amino acids, the building blocks of proteins. This experiment was a game changer. It showed that the basic components of life could form from simple, non-living chemicals through natural processes. This gave a huge boost to the idea that life started right here on Earth. Another popular suspect for life's birthplace is deep-sea hydrothermal vents. These are cracks in the ocean floor where superheated, mineral-rich water billows out from the Earth's interior. These vents are chemical oases in the deep dark. Even as some scientists look to the stars for answers, others are redoubling their efforts to find a homegrown solution. They believe we don't need aliens to solve the puzzle of life's origin. One of the most intriguing new ideas comes from a team led by researchers at the University of Leeds. They propose a mechanism that could bridge the gap between simple chemicals and the complex polymers of life. Their work revisits the idea of lightning, but on a much smaller scale. They are not talking about massive bolts of lightning from the sky, but tiny, continuous micro-lightning sparks on the surface of early Earth. Their research suggests that on the volcanic landscapes of the early planet, there would have been powerful electric fields. These fields could have been generated by atmospheric processes or by the movement of volcanic plumes. When water trickled over surfaces in these high-energy environments, it could have created countless tiny sparks. These micro-lightning discharges, they argue, provided the perfect energy source to drive polymerization. They could have zapped simple molecules like amino acids and forced them to link together into longer chains. In the midst of these deep scientific debates, the topic of aliens has crashed into the mainstream from an unexpected direction: the United States government. For decades, reports of unidentified flying objects, now rebranded as unidentified anomalous phenomena, were relegated to the fringes. But recently, the Pentagon has been compelled to take them seriously. A 2023 report from its All-Domain Anomaly Resolution Office reviewed decades of government records and investigations. Its conclusion was unambiguous. After all that searching, they found no evidence that any UAP sighting represented extraterrestrial technology. The report systematically debunked famous cases, attributing them to misidentification of conventional objects, secret military projects, natural phenomena. Let's step back from the science for a moment and engage in a little cosmic contemplation. Let's ask, what if? What if Endres is right? What if directed panspermia is the true story of our origins? What would that mean for us, for humanity? The implications would be staggering, shaking the foundations of our philosophy, religion, our sense of self. For all of human history, we have wrestled with two competing narratives: special creation of a divine being, blind, random cosmic lottery. Directed panspermia offers a third way: engineered genesis. We would be neither the children of gods nor the children of chance, descendants of microbes sent by a technologically advanced intelligent species. A deliberate act, a conscious choice by beings we may never know. This would reframe our entire existence. Human history, the latest chapter in a story that began on another world, in another time. Our deepest biological roots would be alien, an experiment.